In this video, I introduce a perceptual metric for image similarity measurement. Perceptual distance measures how similar are two patches in a way that coincides with human judgment. Concretely, if a tuple x0, x, and x1 in a dataset contains two distortions, x0 and x1, and a reference x, perceptual metric evaluates which distorted patch is more similar to the reference, as shown here. This patch 0, this reference, and this patch 1. The distorted patches are generated by traditional methods and CNN-based networks. A variable h represents the similarity of two patches x0 and x1 close to the reference judged by a human. T is a dataset of patch triplets x0, x1, and h. Perceptual similarity computes a cosine distance in each convolutional layer of a network and then averages across spatial dimensions and layers of network as shown here. As a network F to calculate the feature distributions from x0 or x1. This calculates the feature distributions from reference x. To compute the perceptual distance d0 between x and x0 and d1 between x and x1, a convolutional neural network F is used to generate a feature distribution in each layer of the network, as shown here. This CNN F. A small network G on top of the F is trained to predict the perceptual judgment H caret from the distance pair D0 and D1, as shown here. Input is the concatenation of D0 and D1. Output is the prediction H caret. This H is a human judgment. The network F is applied to compute the feature distributions YL, Y0L, and Y1L of the layer L for inputs X, X0, and X1. The activations are scaled channel-wise by vector WL, and the L2 distance is computed. D0 and D1 are obtained by averaging the features spatially and then summing channel-wise. The cosine distance d between x0 and x is defined as here. A simple case for training with perceptual judgment is that fixed the pre-trained network F, we learn linear weight W, as shown here. This constitutes a perceptual calibration of a few parameters in an existing feature space, as shown here. This is the input x1, x, and x0. This h is a human judgment. And then we use convolutional neural network F to generate D0 and D1. Then we use network F to predict the H caret. Then we use this cross entropy loss to train this model to minimize the difference between H and H caret. The loss function for training G is defined as here. The loss function is used to train a small network G on top to map to a score H caret. For more details, please check with these references. Thank you. Bye.